In a previous video, we did some simple configurations of network interfaces, and we saw a little bit about the relationships from vSwitches to port groups to NICs and also to VM kernel ports. So we may not necessarily want to combine the same network interfaces with different types of traffic. In this case, we can see that on my vSwitch 0, I have virtual machines that I'm hosting on a virtual machine port group and also the VM kernel port, and I'm using two NICs. I guess the real question is, once I start having many virtual machines, how are those virtual machines going to be able to use the network adapters that are available? I'm going to go ahead and open up the properties of this vSwitch. And if I go into my network adapters, we can see that we have two of them listed. Not really a lot of options here. But if I go into the properties of the vSwitch itself, it's a little tricky. I mean, it's kind of nested in here. We're in the vSwitch properties already. But to actually access the vSwitch settings, we've got to go through this configuration interface. So if I click Edit, we can see that we have some security options, whether we're going to allow virtual machines to run in promiscuous mode where they could sniff other virtual machines' traffic, whether they're going to be able to change their MAC addresses or forge IP transmits. Of course, normally we don't want to allow those things, but if we're running network load balancing, for example, inside VMware, we may need to turn those things on. So in this case, I could set one set of defaults at the vSwitch, then I could create port groups with different options, or create completely separate vSwitches, but then I'm going to need to have separate NICs. Now that could be a good way to do things, but we're potentially going to have a lot of network interfaces, and it can add to a bit of complexity. If we take a look at the traffic shaping options, we can actually specify that for whatever is attached to this vSwitch, that we're going to limit them to an average bandwidth of whatever amounts of kilobits per second we think is appropriate. We can specify what their maximum transmission rate should be, and they'll be able to send at that rate for a certain amount of traffic, and we can set the burst size for that. But when we get into the NIC teaming, we'll see that we've got quite a few more options, and it's definitely worthwhile to understand how these are going to work and how it's going to impact how virtual machines actually use the network interfaces that are available. So we can see that down in the lower section of the screen, I've got both adapters marked as active. Depending on the load balancing options that we use, and depending on what type of traffic we're carrying there, we may or may not be able to do this. For virtual machine traffic and the VM kernel interfaces that we use to manage the system, we can use the load balancing options, but the default mode is route based on the originating virtual port ID. And effectively what happens in this mode is when a virtual machine is started, its virtual NIC will be associated with one of these physical NICs. And that association won't change unless the virtual machine is restarted. So over time, if our virtual machines have reasonably the same workload profile, we should achieve a certain degree of load balancing this way, and it just works. Each one of these NICs is attached really as a switch uplink, and the vSwitch can maintain various MAC table entries for many MAC addresses associated with it. So that's no problem. But we have a couple of other options here. We can see that we can use the IP hash mechanism or the MAC hash mechanism. Actually, the MAC hash mechanism is pretty well depreciated. If you want to do actual load balancing, then what we can look at is route based on IP hash. Now in this case, we're really creating a NIC team. There's really two protocols that we can use to do that. We have 802.3 AD, which is simple static ether channel, typically is what it's called in Cisco, but does not use the link aggregation control protocol. That is 802.1 AX, although a lot of people refer to it along with 802.3 AD, but that's not supported in the standard vSwitches. If you use the distributed vSwitch, then we can actually say to load balance based on load. But what these do will basically allow us to associate the same virtual machine across multiple NICs. So rather than sharing a NIC like they would typically, one vNIC inside our virtual machines potentially could go out over multiple different network interfaces. So we're going to have to set up Ether channel in a static way. So it's going to require some coordination with our switch management team. And really what we want to do is have one Ether channel for all the interfaces that make up this vSwitch. And it's very important that we do that. If you try to set them up as, two NICs in one team or one Ether channel or two NICs in another Ether channel, you'll have problems, and that's not supported. For all the NICs that go into this vSwitch, now or in the future, on the switches, they're going to have to be associated with the appropriate Ether channel. If you move into the distributed vSwitch and you move over to LACP, we can actually achieve much more load balancing, and we can actually rebalance network connections while there's activity on the system, and we can dynamically rebalance. None of those things actually happen here without the distributed vSwitch. If you're doing this, you're going to need to make sure that it's all set up correctly. You'll notice that there's a bit of a warning here telling you that you know you're going to have to set your switch up and it's going to have to be done the same way for all port groups using the same set of uplinks. It should go out and touch all our port groups automatically, but we definitely want to make sure that it does. So it's a good idea to go through our different port groups and our VM kernel ports and make sure that it's either not overriding, or if we do decide to mark it explicitly this way, that we choose the right options. And I've heard some cases about the management network not always inheriting these settings correctly. So definitely a good idea to go in and make sure, because all these overrides are set, that it is done correctly. So we might want to take off these overrides or override it manually to be the right option. I guess that's the default environment, is just to block those. So if you've already removed and recreated your own, you might not have this problem, but out of the box, it does do this override. So we want to be aware of that. Now, depending on how we're actually connected, we may or may not be able to do network failover detection. So if we just check for the link status, that could work well, but all it's really telling us is that that network interface is connected to an upstream switch. We don't necessarily know that that upstream switch is connected to anything else. In cases where we use 3 or more adapters connected to 2 different switches, what we can do is we can go into beacon probing mode, and all the interfaces will actually communicate with each other, and that's going to help us tell whether or not we really have healthy networking or not. Because we've got to cross out from the server to the switch, but then the switch has to cross over to the other switch as well. So that'll help us ensure that trunking and stacking and all of those things are configured correctly. And depending on the load balancing mode we're using, when we do a failover, we may actually need to go out and do things like gratuitous ARP updates to the switches so that they know that they need to update their cam tables, things like that. So we can specify whether we want to do that here or not. And if we have set preferred adapters, if we're using active and standby adapters, and we're using one of the standbys and one of the actives becomes available again, do we want to fail that traffic back or not? Typically you would, no real reason not to. The only other thing that I really want to point out here, in addition to these options, is a little bit about trunking. If you want to carry VLAN traffic inside VMware, we could physically attach different NICs to the vSwitches and then put those NICs physically on the physical switches into specific VLANs by saying, port 1, port 2, port 3 make up VLAN 1, or ports 1 through 50 make up VLAN 2, or whatever. That can work, but it's going to be difficult when we get into an environment with dozens or hundreds of VLANs. It's going to be quite difficult to provide redundant, well-performing network interfaces. If I go into, say, this VM network port group, I can go into its properties and I can just provide a VLAN ID. Now, this is actually going to require us to be configured in a pretty specific and special way. When you want to do VLANs within a single switch, it's normally easy to do. We actually can't do that in a VMware vSwitch, but typically on a switch that supports VLANs anyway, we could pretty easily go in and just say port 1, 2, 3, and 4 goes with this, and 5, 6, 7, 8 goes with something else. When we start trying to do that across switches, that becomes a little bit different. And when we want to start using VLANs across switches, we normally need to configure those switches in a trunked configuration. We attach the switches to each other, and we basically tell them to share the information about their VLAN databases so that we can actually carry traffic from one switch to the other and have them be in the same VLAN. So this is basically a soft VLAN type concept, where everything attached to the switch doesn't necessarily know anything about the VLANs, but the switch says, oh, traffic coming from these ports, add a VLAN identifier to its traffic so that the other switches know where it came from and they can put it in the right VLAN. So what we can do now is carry that idea into VMware, and our vSwitches or the DV switches can also operate in a trunked way with our switches. Once we are configured in a trunk-oriented way, then our switches will see our vSwitches as peers and we'll be able to exchange this type of VLAN data. You may want to look at the distributed vSwitch and potentially even replacing the VMware distributed vSwitch with something like the Cisco Nexus 1000 vSwitch, in which case it's actually a Cisco switch implemented in software. Your various Cisco management tools will work with it, and your various Cisco protocols will also work with it. So that's definitely something to consider. So that can all be useful and is going to require quite a bit of coordination with your network management team, but it's definitely well worth doing, and definitely review the VMware literature talking about the different load balancing modes, what the configuration on your network gear has to look like, and different ways that we can plan how to carry traffic. So these load balancing options are available for virtual machine traffic and also for management traffic for VM kernel interfaces, but we can't use them with iSCSI or with vMotion. However, we can use them with NFS. So if you're using NFS storage, typically we're going to want to dedicate certain NICs to that. If we want to team those NICs, then we can do that. But to do this effectively, when we're talking about load balancing based on IP hash, it's really a hash of the source and destination server combined. It's really best if we have multiple remote IP addresses as well. So our NFS server, rather than just presenting it over one address, better if we present it over a couple of different addresses to make sure that that load balancing is actually going to work well. Most of the time, we don't really need to worry about that because we have lots of clients coming to a small number of servers. So the way the IP load balancing works is usually okay. But where we have a small number of IP addresses connecting to another small number of IP addresses, we may not have enough connections and so on established to actually make that load balancing work effectively. For a bit more information on all that, take a look at some of the other networking videos and also take a look at the storage videos for iSCSI, where we're going to take a look at how we can do a proper failover setup for iSCSI, which is actually not done using teaming at all.